All right, this little video is designed to help you with one of the homework questions. Homework number 3. And it's connecting this labeling technique we have with SDS PAGE, which is a way to analyze proteins. Okay, so this is figure, I think 722? Yeah. (722), 724 if you're using the 8th edition from your textbook. Okay. And lactoperoxidase is an enzyme that can connect a radioactive iodine to a protein. So it's a way to label it so that we can detect it. All right. One of the things I want you to make sure is there should be a line here in your figure in your textbook showing that protein C in this diagram is labeled by I-25 in the bottom. With radioactive labeling, anything that has this radioactive tag on it will be visualized on a gel, and I'll show you that in just a second. Something else that you can't exactly see from this diagram, so we're going to make up or designate, is protein size. Because if you remember, SDS PAGE is going to separate proteins based on their size. So I'm just going to tell you right now that we're going to designate protein B being larger in size than protein A, being larger in size than protein C. Okay, so this is the kind of data that you're getting in question number 3. So let's make sure we understand a gel image. Okay. And I had to fix the lane information on question 3. So I've revised the homework and told you this is lane M. The first lane is always the marker. And the marker means they're proteins of specific size. So these are known, you purchase them from a biotech company, and when you run them on the gel down here, they're going to separate out and you know the size of them. Okay, so the marker we're going to use for this video is something that has a protein that's 10 kilodaltons, 6 kilodaltons, and 3 kilodaltons. So when we draw these images, even though we're loading everything in the lane and then applying electricity and everything's moving, we're just going to show the end result. Okay. Remember, the larger proteins are up top, the smaller move faster, so they're near the bottom of the gel. Okay. Each, what we call lane, like lane 1, lane 2, lane 3, lane 4, each lane contains one sample. So in your homework, you have 4 lanes. So we've done 4 different experiments. We've taken all the proteins from that experiment, put them into a lane, and separated the samples. Okay. So for your gel, you have 4 data lanes from each experiment. So lane is the vertical. Okay. Now let's erase some of this stuff on my gel. Okay, this little rectangle is called a band. Okay, and a band means what you can see, and it's a group of proteins of about the same size. Okay, so in this case we have a 10 kilodalton protein band. So everything that's the same size Oh, darn it, why did it do that? Everything that's the same size, regardless of the experiment, would run the same spot on the gel. So this is proteins, I'm having trouble writing today, proteins, all same size. Okay. Now, not every experiment are you going to see every protein. It depends on how we're labeling it. And that's what I want to show you next. So, let's take the first part of figure 722, where they're labeling the exterior proteins. Okay, so remember that they're showing you this little liposome, so a membrane, phospholipid bilayer with some proteins A, B, and C are proteins that are associated with the membrane. So the first thing they do, or we do, is we add lactoperoxidase and I-25. And that means that these chemicals are floating around the outside of the membrane. And so anything that is exterior is going to get a radioactive I-125 label. Okay. C is on the inside. C doesn't get labeled because the lactoperoxidase and I-25 are out here. So when we take this sample and say run it in, oh, I forgot, let me back up. So now we need to release the proteins from the membrane. Okay, so I'm going to use detergent. And in your homework, you have different conditions that release different membranes. Detergent releases all proteins. Okay, so detergent breaks down the membrane, releases all proteins for analysis. Okay, whoops. Remember, we can only see, we can only visualize, darn it, what did I do? We can only visualize the radioactive proteins. Okay. So when I run these proteins, let's just clean off this. Okay, so we have our I-25, I-125, sorry, right, labeled. And we're going to run this sample plus detergent that destroyed the membrane on the gel. Okay, and what we're going to see is we're going to see two bands representing the two different proteins that were labeled. So let's just say we get a band here. Darn it. We get a band here, and we get a smaller band here. This larger one is going to correspond to protein B, right? Because I told you B is bigger than A. And this smaller one is going to represent protein A. So all of our samples from this one experiment were run in lane 1. They're separated based on size, and only the ones with radioactive iodine can be seen. So protein C might be down here somewhere, right? But we can't see it because it wasn't labeled with radioactive iodine. Make sense? So we've got one experiment, and we know that lane 1 is exterior proteins. All right, now go to the next slide. Okay, so let's put in our lane 1. So we had this band, and where did I have it? We have this band. Okay, so now we're going to say this is experiment 2. Okay. This part of the experiment labels the interior proteins, because what you do is you put the membrane in a hypotonic medium, right? Low solute, lots of water, so the water drives in the lactoperoxidase. So now the enzyme is on the inside. And then you add the I-25, which is so small it can just go right into the interior also. So now any protein that's on the inside of the membrane, the interior proteins, will be labeled. Okay? And so for experiment 2, we labeled the interior proteins. We added detergent to release all the proteins. We run it on lane 2, and of course we're going to get protein B showing up again. And now we're going to get protein C, right? So we know from our experiments, because of the size, this band refers to protein B, this one A, and this one C. From this data tells you, let's see if I can change my ink color. This data tells you that protein B was labeled on both the exterior and the interior, right? From experiment 1 and experiment 2. That means protein B must cross the membrane, right? It must touch the outside and the inside. From this experiment, we know that protein A was only on the exterior, right? And so you would draw it right here on the outside of the membrane. And we know from this combination of experiments that protein C was labeled from the inside. Right? Okay, I just couldn't remember what my last slide was. Make sense? All right, so when you put this set of experiments together, you got the data that looked like this, and you knew experiment 1 was interior proteins, experiment 2 was exterior, and they both were for all proteins. Now you have some that are released, proteins are released by different treatments. Okay. So not every protein will show up. It depends on how you're treating the membrane. Remember, detergent shows everything that's labeled. Other things show their interactions with the membranes. Okay. So you're given this data, and what I want you to be able to draw is this. I want you to tell me which are transmembrane proteins, which are only interior, which are exterior, and then there's a little bit more information to do. But that's how you go between lactoperoxidase labeling and SDS PAGE. I hope that helps you all.